Complexometric titration is a type of volumetric analysis that uses a complexing agent, usually a multidentate ligand, to form a stable complex with a metal ion in solution. The end point of the titration is detected by a change in color, pH, or potential of the solution, or by using an instrumental method. Complexometric titration can be used to determine the concentration of metal ions in solution, or to separate and identify different metal ions. There are four main types of complexometric titration, depending on the method of titration and the indicator used. 1. Direct titration. It is the most convenient and simple method of complexometric titration using EDTA. It is similar to the acid-base titration technique. The metal ion solution is titrated with a standard solution of EDTA until the end point is reached. The end point is indicated by a metallochromic indicator, such as areochrome black T, that changes color when it binds to the free metal ions or the metal EDTA complex. 2. Back titration. It is called back titration as in this type of titration, we perform back titration for the excess amount of EDTA. It is used when the metal ion solution is too concentrated or too turbid, or when the metal ion forms a precipitate with EDTA. In this case, an excess amount of EDTA is added to the metal ion solution, and the excess EDTA is titrated with a standard solution of another metal ion, such as Mg2+ or Zn2+, until the end point is reached. The end point is indicated by the same metallochromic indicator as in direct titration. 3. Replacement titration. It is used when direct titration or back titration don't give sharp endpoints. It is also used when the metal ion forms a very stable complex with EDTA, such as Cu2+, or when the metal ion interferes with the indicator, such as Fe3+. In this case, the metal ion solution is treated with a masking agent, such as cyanide, that forms a more stable complex with the metal ion than EDTA. The masked metal ion is then replaced by another metal ion, such as Zn2+, that forms a less stable complex with the masking agent. The released metal ion is then titrated with EDTA until the end point is reached. The end point is indicated by a metallochromic indicator, such as murexide, that changes color when it binds to the released metal ion or the metal EDTA complex. For indirect titration, I used when the analyte cannot be titrated directly. It is also used when the analyte is not a metal ion, but can react with a metal ion to form a precipitate or a gas. In this case, the analyte is reacted with a known excess amount of a metal ion, such as Ag+ or Hg2+, and the unreacted metal ion is titrated with EDTA until the end point is reached. The end point is indicated by a metallochromic indicator, such as eosin, that changes color when it binds to the unreacted metal ion or the metal EDTA complex.
Johnson Classes.
The best for best.